Hola a todos, soy Javier Poveda y esto es De Bien TV, el canal en el que te lo vas a pasar de bien aprendiendo geografía, historia e historia del arte. Este vídeo va dirigido a los alumnos de primero de la ESO de sección del IES Neil Armstrong de Valdemoro, en concreto a los de los grupos D y E, que son a los que yo les doy clase habitualmente. En esta clase que vamos a ver a continuación, vamos a hablar de los contenidos finales de la Unit 4, which is about the weather, y de los de la Unit 5, which is the Introduction to Climatology. Antes de empezar con la clase, quiero hacer un par de apuntes. Uno, desearos que todos estéis lo mejor posible de salud, vosotros y vuestras familias. Y segundo, pues que me perdonéis un poco las pintas, porque como sabéis no hay peluquerías abiertas y tengo un poco de, pues de greñas, ¿no? Y que si me las dejo sueltas, el pelo me cubre los ojos y no podría dar ni hacer esta clase. Dicho esto, vamos a empezar con la lección y vamos a empezar con la parte de la Unit 4. Vamos a ello. So, we are here in the presentation of PowerPoint of the Unit 4, the part of interpretation of weather maps. Here it is. So we have to know that in the weather maps we have anticyclones and depressions, which we know already what they are because we have studied there before. And we have to know that anticyclones and depressions are represented on maps using isobars, which are lines connecting areas or points with the same atmospheric pressure. What does this mean? This means that, for example, this line, this isobar, which I am pointing right now with the pointer of my mouse, this means that here in this point the pressure is 1028 millibars here and here and here and here and here. For example, in this point, what is the pressure? The pressure is 1020 millibars as you can see here, here and here. So what is a millibar? A millibar is the same as a hectopascal, which is the unit we use to measure the atmospheric pressure, but the most common one is the millibar. We have to know that the pressure at sea level at 0 meters of height is 1015 hectopascals. So if the pressure is above 1015, we name that as an anticyclonic area, and if the pressure is below 1015 millibars, we name that as a depression. So in the weather maps, you can see that the anticyclones are represented with an A letter and the depressions are represented with the B letter. In some English weather maps, you will see this instead of A and B with an H, which means high pressure, and an L, which means low pressure. But since we are used to look at this type of maps in Spain, I'm showing this one to you. So anticyclones form and depressions more or less concentric isobars with maximum values in the center. As you can see here, this is the center of the anticyclone, and the highest value of pressure is here next to it, which is 1032. As we get further from the center, the value decreases. Here we have 1028, 1024, 20, etc, etc, etc. And in the depression, it happens the other way around. Next to the center of the depression, the pressure value is the lowest. Here it is 1004. Then if we go further, we have increasing values, 1008, 1012, 1016, etc, etc. So they always form these concentric circle shapes. So when we first look at a weather map, we have to identify which are the most important elements. Here, depressions and anticyclones. here the lines are the isobars with the numbers representing or measuring the atmospheric pressure in millibars as we saw before. And also we can see sometimes if you are watching the news, for example, in Televisión Española, which is the best weather news that are broadcasted in Spain, you will also see, for example, these kind of lines. These blue and red lines are the fronts. The red line is a warm front and the blue line is a cold front. This means that big masses of air which are moving towards the direction of in the warm fronts, the direction of these little red semicircles. For example, this warm front, which I am pointing right now, is moving towards the north. You see that? And this cold front moves towards the direction which are pointing these little blue triangles. For example, this one is moving here to the north and here to the east, crossing the Iberian Peninsula. Also, as you know, we can guess which are the direction of the winds because, as you should know, because we have it is earlier in the presentation, the winds move from the high pressure areas to the low pressure areas. So the nature tends to look for an equilibrium. So from the wind is going to move from these high pressure areas to these low pressure areas. Why? Because they get more or less equal over time. So here, which are the high pressure areas? The ones next to, pardon, the ones next to the anticyclones. As you can see, 120 and 116, which are the low pressure areas. Here, these isobars, which have the value of 980, 984, etc. So the winds are moving from this area to this area to get an equilibrium. And since the distance between these isobars is very short, we can expect the winds to be very intense. As you can see, the closer the isobars are, the more intense the winds are because the equilibrium is going to be achieved before. But here in this area, since the isobars are very far away from each other, the winds should be more calm, okay? That's what I'm pointing here. This is a calm wind area and this is an intense wind area because the isobars are very close to each other. For example, we are going to look to some climatic situations, some typical climatic situations. This is a map which is showing good weather conditions. Why? Because this is an anticyclonic situation. Here in Spain, always we are looking this from the point of view of us, of the Iberian Peninsula of Spain. Here we have a big anticyclone which isobars are all over the Iberian Peninsula. The pressure is high because it is above 1015 millibars, so we can expect to have good weather this day, which is July the 2nd of 2007. On the other side, we can pardon, we can find also cyclonic situations which are usually connected to bad weather conditions. Here we have two big depressions on the northwest of the British Islands and a lot of isobars which are showing low pressure areas. And those are all over the Iberian Peninsula, and also we have a cold front here. So we can expect to have very intense winds in the Iberian Peninsula and bad weather conditions, low temperature, the intense winds that I said before, and probably a lot of rain. So for example, if I give you, perdón, estoy con la garganta un poco hecha polvo. If I give you this kind of map, what would you say? Here we have a depression with low pressure isobars, 1000, 1004, 1008 millibars, which are here all over Spain. We also have a cold front, which means that they usually bring rain with them, and also here a cold front, a warm front, sorry, which is leaving the peninsula towards the north. So since we have a depression here which is affecting the Iberian Peninsula, what we can expect? Yes, this is an example of a cold drop. This is the weather map that you usually watch on the news after the sports news. And here you can find that, you can see that in most of the Spanish territory is raining and there is a lot of wind blowing towards the north. Okay? And if you remember, this is called a cold drop, la gota fría, or Dana, which, if I remember correctly, we had a big one last year, in 2019, which caused a lot of disaster in many areas of the coast, of the eastern coast of Spain. Here, what do we have? We have in the Iberian Peninsula, we have an anticyclone here and a depression here. So which are the lines that are the isobars that are crossing the Iberian Peninsula? We have here 1004, 1008, 1012, and 1016. So they are low pressure areas, low pressure lines. So, and also we have here a cold front which is traveling through the peninsula towards the south, and another one that has just left the peninsula. So what can we expect from this? Cold weather wave, una ola de frío. Why? You have to notice that even though it's a cold weather wave, it doesn't mean that it has to be cloudy or it has to be rainy. Okay, it can be sunny, but the temperature it's low. Okay, for example, here in most of the country we have sunny weather conditions, some cloudy conditions here in Castilla-La Mancha, and some rains in the Canary Islands and the western part of Andalusia. Why is that? Because we have here low pressure and we have two cold fronts here that bring rains with them. And finally, here we have another weather situation in which we can see this big anticyclone, which is the Azores anticyclone, which is affecting the Iberian Peninsula with high pressures, I remember you, over 1015 millibars. And we can see that the lines are very far from each other. There's a big distance between, a long distance between each of the isobars. So what we can expect, and also because the fronts are very far away from the peninsula, what we can expect from this, this is a summer weather condition. We have sunny weather conditions all over the country, some clouds here on the coast, in the eastern coast and in the north coast. And why is this the average weather conditions in summer? Because oh my god, because we have here, because the fronts are very far away from the peninsula and the isobars are very far away from each other, so that means that the winds are very calm and the temperatures should be high. Okay, and this is the end for the Unit 4 presentation. Now we are going to switch to the Unit 5. Let me change it in the video here. Let me check it out. Here we have. Okay. So now you get this. So now we are going now to start with the presentation of the Unit 5, which is Introduction to Climatology, and we are going to take a look at the climate elements, the temperature, the precipitation, and the types of climate in the world and in Spain. Finally, we will learn how to create and interpret a climate graph. So what do we have to know about the temperature? We know that in the atmosphere the temperature is not over the same all over the planet. We have temperate, tropical and polar zones, and these are determined by factors such as latitude, altitude and distance from the sea. So first, how latitude affects temperature. We have to know this concept, insolation. The insolation is the amount of solar energy that reaches the Earth. This is measured in a location on Earth and it depends on the latitude. Here you have a diagram which shows it very clearly. Here in the medium part of the Earth, in the equator, the solar radiation is concentrated over a smaller area, so it is very intense and it hits more the planet. Here in further latitudes, the solar radiation is concentrated over a larger area, a bigger area, so the intensity of the isolation is much weaker, okay? If you remember, we made an experiment, in class when we turned off all the lights and I took my cell phone out and I pointed the lantern of the cell phone to the wall of the class. And I tried to explain you how this works. You remember with the cell phone pointing at a 90-degree angle in parallel, well, the direction of the light was perpendicular to the wall. The light was concentrated in a very small area, but if I turn the mobile phone up and down, the light was spread all over. Dios mío, was spread all over the wall of the class and the intensity of the light was much weaker. So the insulation, this is how insulation works, okay? I hope you understand because I explained this to you several months or weeks ago. I'm not sure, but here it is shown very clearly, okay? Here the sun is more intense, the solar rays are more intense because they are concentrated and this area here is much larger than this one, so the intensity is lower, okay? So at the equator, solar rays hit the Earth at a very direct angle. It's close to 90 degrees angle, like this. Therefore, they are concentrated in a smaller area and insolation is intense. As we move further from the equator, further here from the equator, the solar rays, or the sun rays, hit the Earth at a less direct angle and cover a larger area, so insolation is less intense, okay? It's not the same if the sun rays hit here in this part than if they hit here. So the latitude determines some climate zones. The main ones are the following: the tropical zone between the Tropic of Cancer, this one, and the Tropic of Capricorn, this one in the southern hemisphere. This area has high temperatures all year round. Then we have the temperate zones, one in the northern hemisphere and another one in the southern hemisphere. They are between the tropics and the Arctic and Antarctic cycles. Okay, in these zones, in which one in the northern part is Spain located, the temperatures vary with the seasons. For example, in the northern hemisphere, in summer, which is in the northern hemisphere in July and August mostly, the temperatures hit their maximum, okay, in summer. But in winter, as we are now, in January, February, and March, the temperatures are the lowest. This happens in a similar way in the southern hemisphere, but with the seasons exchange. No? For example, right now in Argentina or in Chile, they are in summer and they have high temperatures. Whilst in here now in Spain, we have low temperatures because we are in winter. Right now, there is you cannot go outside. Well, you cannot go outside because we are in an alarm state. But, or I don't know how it is said in English, estado de alarma. We cannot go outside. But if you go to your balcony, for example, you will notice that it is very cold outside. And finally, we have the polar zones, both at the North Pole and the South Pole, with very low temperatures all year because the sun rays hit at a very, how do you say this? not perpendicular angle, okay? Very leaned. How do we say this? So not very direct angle. I cannot find the word right now, I'm sorry, but I'm sure you know what I mean. Then we have another factor that affects temperature is the altitude. The altitude is the height of a place on Earth relative to the sea level. So counting from the sea level, the air closest to the Earth's surface is warmer. So here, to the Earth's surface, the book means closest to the sea level, to 0 meters of altitude. The temperature drops the higher we go, and because the air is less here, here is a typo because there is an S missing, less, L-E-S-S. The air is less dense and does not retain heat. So the higher we go in altitude, the lower the temperature is. This has a formula, and it's around the temperature decreases more or less 6.4, 6.55 degrees centigrade for every 1,000 meters of altitude. As you can see here, at 0 meters, we have, for example, 30 degrees of temperature, but if we go up, or if we climb this mountain and we are at a point at 1,000 meters, the temperature has decreased more or less 6.5, or more or less no, exactly 6.5 degrees, and then another 6.5 and another 6.5. So the higher we go, the lower the temperature is. That's how altitude affects temperature. Finally, we have the distance from the sea. In coastal areas, temperatures are mild all year round. Mild means warm, temperate, templado. Why is that? Because the seas and oceans regulate temperature. This is a typo also. This is because of the dictionary of the Microsoft Office, which automatically changes the words because I'm not able to change the dictionary of the program. I'm sorry. This is temperature ending with an E. As the weather heats up and cools down more slowly than the land, okay? So the air over the sea warms the land near the coast, resulting in milder temperatures in coastal regions. In coastal region, we have a higher temperature and a high temperature and a low temperature, and they are not very far from each other in a graph. For example, in Madrid, which is far away from the coast, the higher and the lower temperature are very separated from each other, and that's because the sea acts like a regulator of the temperature. Okay, so the closest we are to the closest we are to the sea, the mildest the temperatures will be. So here we have a map. This map is on the book. Actually, this is a photograph of the book because I couldn't find it on Google, with the world average annual temperatures. In this map, you can see these lines which are called isotherms. This means that similar to the isobars, which were lines connecting points with the same pressure, the isotherms are lines connecting points with the same temperature. Okay, so for example, the average annual temperature in this point is 10 degrees, here is 10 degrees, here 10 degrees, here 10 degrees, and so on. So the highest average annual temperatures above 20 degrees centigrade are found between the tropics and of Cancer and Capricorn. So more or less in this area close to the equator, which is colored in orange and dark red. The coldest areas, which average annual temperature is below 0 degrees centigrade, are located both at the north and the south pole here in Antarctica. And between these cold areas and the hot area near the equator, we have the temperate zones, which average annual temperatures goes between 0 and 20 degrees centigrade. Here in Spain, we are located in one of these temperate zones. Okay. The second element of climate are well, is precipitations. So the distribution of precipitation on Earth varies according to the climate zones. The wind, the atmospheric pressure, and the relief are determining elements. We can see, well, here you have also a kind of summary here, which summarizes very well. So we have that in the tropical zone, in the areas close to the equator, the precipitation is abundant because it rains all year round. In these areas, we have two seasons, a wet season with high rainfall and a dry one with little rain. In the temperate zones, on the other hand, there is more precipitation near the sea because the warm air absorbs more water vapor from the warm sea and the ocean currents. Remember that we studied the ocean currents earlier in this unit, no, in the previous unit. And on the other side, inland, further, further from the sea, there is less precipitation because moist winds do not travel that far. Moist means that moist winds means that the wind has humidity, vientos húmedos. And the deserts form where rain is scarce, where there is very little rain. For example, in Spain we have an area in the southeast, the zones of Almería, Murcia, el desierto de Tabernas, for example, which are some kind of they are deserts because there is very few rain. And finally, in the polar zones, the precipitation is very low. Why? Because there is little sunlight. Remember the insulation. The water freezes and does not evaporate. What do we have also here? The relief also plays an important role in precipitation. Why? Because the moist air when the moisture meets an obstacle in its path, for example, a mountain, it rises, it goes up, it cools here. This is hot wind, or warm wind, and here as it goes up, it gets cooler and becomes saturated, causing precipitation. Here it's raining in this side of the mountain because the air, which is charged with has a lot of humidity, gets colder, and when it gets cold enough for the point of condensation, then the precipitations appear. This rainfall is called orographic or relief precipitation. Also, this is called the Foehn effect because the geograph that discovered this was a German one, and you may find it with its name, the Foehn effect. We don't have to know it. So here you have a world map with the average annual rainfall, which is the amount of precipitation that occurs in one area all over a year. Here you have lines which are called imaginary lines, which are called isohyetes. Isohyetes. I am not sure how to pronounce this, which are used to show rainfall on the map. For example, this line means that here there is 1000 millimeters of precipitation, here also, and here also, and here also, and here also. Okay, all these lines, isoderms, isobars, and isohyetes work more or less the same way. These lines connect places on the Earth's surface with the same amount of rainfall, as I said. Depending on the total annual rainfall in an area, we can talk about very wet areas over 1000, which is this dark blue, 1000 millimeters, wet areas between 500 and 1000, which is the light blue, these areas here, dry areas between 250 and 500 millimeters in green, and arid or desert areas, which you have in yellow. For example, here the Sahara Desert or the Arabic Desert, or the polar zones, which we saw later, earlier, that they had very few precipitation. Then we have to take a look at the Earth's climates. This is only an introduction to climates. We will see the climates more in detail in the following unit, but we want you to have a superficial look or an introductory look at them. So the Earth's climates are classified as extreme and temperate depending on precipitation and temperatures. The temperate climates are located between 30 degrees and 60 degrees of latitude in both hemispheres. So this should be, well, this is the temperate zone. I couldn't find the map in English, so I have to use the map in Spanish. This is the temperate zone of the northern hemisphere, and this is the temperate zone of the southern hemisphere. Depending on latitude, altitude, and distance from the sea, we can find three types of temperate climate. The oceanic, here in this kind of green, it is blue-green, I don't know. The Mediterranean, here, for example, most of the Spanish territory is or has a Mediterranean climate, and continental climate, which is this light green one. We will study them in detail, as I said, later, well, in the next unit. Then we have the extreme climates that are, I cannot see the pointer of the mouse, yes, here it is, that are located in the polar and the tropical zone. We have several types, 5, which are equatorial, tropical in red, tropical in light brown, the desert in yellow, polar in blue, and high mountain in brown. Okay. What do we have in Spain? I had the same problem here. I couldn't find a proper map in English, so I had to use this. I'm sorry. The climate on the Iberian Peninsula and the Balearic Islands, as we said before, as we saw before, is temperate. We have 4 subtypes in Spain, which we will study in the following week, I guess. They are Oceanic or Atlantic in all this northern area, Galicia, Asturias, Cantabria, País Vasco, and part of Navarra. Then Mediterranean, which is here in light in dark orange color, which is the usual climate located in the coastal zone of the coastal Mediterranean zone of the Iberian Peninsula, in the east, in the Balearic Islands, and in some parts of the south of Spain. Then we have the Mediterranean continental, which is this light yellow, which is the climate that we have in Madrid, for example, and it covers all of or most of the center of the Iberian Peninsula. And finally, the mountain climate, which is located in the pardon, which is located in the big the big mountains of the Iberian Peninsula, such as the Pyrenees, the Cantabrian system, the Central system, the, how do you say this? Sistema Bético. I'm not sure how to say this in English. Here in Andalusia, etc. And we have fifth type of climate, which is the one of the Canary Islands, which is here. It is, since the Canary Islands are located in a lower latitude than the rest of Spain, they have their own type of climate, which we call subtropical climate. They have high temperatures almost all year long and low and irregular precipitation. And finally, this is the most important part of the unit. We are going to, we have to get used to study and to create climate graphs. Climate graphs or climograms, climogramas en castellano, they are graphs that show us the average temperatures and monthly precipitation for a place in a year. It allows us to identify the type of climate. We will study the climates in the next unit, and you will see that each climate has a type of climate graph with which you can identify very quickly what type of climate it is. Here, for example, we have the climate graph of Valdemoro. We have to take a look at this, well, first at the horizontal axis, which shows the months, the vertical right axis, which shows the precipitations in millimeters, and the left vertical axis, which shows this part, not this part, which are degrees Fahrenheit, this part, which is degrees centigrade, which are the ones we use. That shows the temperature. We have to measure to magnitudes here. We have to take a look which are the temperature, this line that connects the points with the monthly average temperature that happens each month, and then the precipitation, which are these blue bars. We have one for each month that they go up until the amount of precipitation that occurs in that month. For example, if we take a look at today, we are in March right now. Here in March, in Valdemoro, we expect to have more or less. Here is the temperature in the middle of the column. So where is the cursor? Here. So the average annual temperature in March in Valdemoro is what it is. 10, this is the point, 10 degrees centigrade, and which is the monthly precipitation of Valdemoro in March. We take a look at this blue bar, we go to the right, it should be around 37, 38 millimeters, okay? So how do we make a climate graph? It is very easy, and here are the steps. First, we have to draw the horizontal axis, and we have to divide it in 12 parts, which are the months of the year: January, February, March, April, May, June, etc. etc. Then in both the two vertical axes, in the one on the left, you have to draw the temperature, okay? You have to put the 0 degrees centigrade. You have to include a bit of negative values, because we will study climates with negative values. And you have to draw the values here. 5 by 5, it's my advice. If you do it 5 by 5 degrees centigrade, 5, 10, 15, 20, 25, etc. On the right vertical axis, you have to draw the precipitation, okay? At the same point of the 0 degrees in temperature, you have to put the 0 millimeters of precipitation. And then you have to draw the values, which are here in intervals of, that's my advice also, intervals of 20 millimeters, 20, 40, 60, etc. It is important that when you draw both the vertical axis, you put here in the precipitation double the value of the temperature which is in the same position. For example, if here you have 10 degrees, at the same height in the graph, you should write 20 millimeters, which is 10 multiplied by 2. Here, 20, you should write here 40, and here 30, you should write here 60, and so on. You will see later why, because we can, if we do this like this, we can identify very quickly which months of the year are arid. Then after we have done this, we have to put the data that we have in from a table like this. This is usually how do we get the data tables of the climates. Here you have the months, and here you have the temperature of each month, the average temperature of each month in degrees centigrade, and here you have the precipitation in millimeters, okay? So we have to move this data to our graph. Before this, it is, here you have it, it is interesting, in order to get a better interpretation of the climate, to calculate the annual average temperature. How do we do this? We have to add up all these values and then divide it by 12. So we get an average annual temperature of 14.66 degrees centigrade. Then we have to also calculate, it is interesting, that we calculate the total annual rainfall. So all the amount of rainfall that occurs in an area or in a location all over the year. What we have to do is the addition of precipitations of each month. You have to add this plus this plus this plus this plus this, and we have a total amount of rainfall, which is here in this example 416 millimeters. So what do? We have to first draw the temperatures. We draw a point in each month here. We draw the point of the average temperature. For example, here we have January 7 degrees, February 8 degrees, March 11 degrees. January 7 degrees, February 8 degrees, March 11 degrees. We do this with the rest of the months, and then we connect all the dots that we have drawn before with a red line, okay? After that, we have to draw the precipitation. The precipitation is drawn with blue bars, and they have to reach the height of the value that is given. For example, we are going to use this part because it is closer to the axis of the precipitation. Okay, here I forgot to translate this. This is temperature, this is precipitation, I'm sorry. For example, in October, November and December, we have 50 millimeters of precipitation, 37 and 25. Here, more or less 45, 37 more or less, and 25 millimeters. Okay, we do this with all the months, and then we have our climate graph completed. So what is the activity I want you to do besides all the activities from the textbook? This is the last activity I wrote you in the email of Tareas 2, which I sent you yesterday. Well, today is Wednesday, yesterday, Tuesday. So here I gave you a table with data from a climate. Okay, here you have the temperatures, the average temperatures for each month, and the amount of rainfall of precipitation and of each month. You have to draw a climate graph such as this one. You have to draw the axis, then draw the line of temperatures, and then draw the bars of precipitation using this data. Okay, this is one of the activities, and then you have to answer the following questions. Here you have. And this is what you have to give to me the next week. I think I told you to do this. So this is the end of the presentation and the end of the lesson of today. Let me change the camera. There. So I hope you enjoyed this class. I hope you understood all of it or most of it. If you have any doubts or any questions, you can, when you want, at any time, you can write to me at my email, didascalosjavi@gmail.com, and I will answer you very happily to every concern that you have. Dicho esto, volvemos al castellano. Espero que os haya gustado y nos vemos en la próxima clase. Muchas gracias por haber estado ahí.